discovered there were oil seeps up and down the Camino Real, California, up and down from LA to San Francisco, had all kinds of oil seeps. All right? People would use that oil to lubricate squeaky wheels on their covered wagons. All right? What else to do with it? Who knew? All right? Who knew? All right? It rises up, but usually it gets caught. It's called a trap rock. It gets caught by a bowl-shaped anticline, where rocks are folded like a bowl. A layer of shale is impermeable. It's like a bowl. It's what a bowl is made out of. It's like mud. So it rises, or it hits a fault zone, or it hits a salt dome. And I'll show you all this. A lot of the natural gas and oil rises up and gets trapped. And then it starts accumulating, starts accumulating, starts accumulating. And we are still finding this stuff. All right? And so, what do we do with crude oil? Well, first we didn't know what to do with it. But now, oh boy, gasoline, diesel fuel, jet fuel, heavy fuel, liquefied petroleum gas, and then all the other stuff. Rubber, asphalt, plastics, nylon, all kinds of solvents and chemicals and pharmaceuticals. All right? Fingernail polish. All comes from petroleum. It's amazing. Plastic. And so oil, a lot like coal, it's 83% or about carbon. It varies quite a bit. We'll have some sulfur in it. So it sinks down, gets buried, heat and pressure, and then it rises up into various pockets. And look at that. Here is the Black Sea. And look at all the phytoplankton. A real bloom of one-celled phytoplankton, living and breathing and dying, and living and breathing and dying, and sinking to the bottom, making new hydrocarbons to get buried, okay? But the accumulation is slow, slow. All right, so there it goes. Well, who's got it? Saudi Arabia, you knew that. But did you know Canada is number 2? Wow, I didn't either when I got into this topic. And these keep shifting. Iran, Iraq, Kuwait, there they all are, the Middle East, Venezuela, Russia, Nigeria. Where are we? USA, we don't have much. Now, it used to be we had it all. We discovered it. We discovered oil in this country, and we went for it. All right, Pennsylvania, first off the list. And so we dominated the market. But soon we helped others find their oil. We did. We took our technology. And we wanted the money. Wow. Crazy. So, and in the United States, Texas is number 1. 2 is Alaska. 3, California. 4 is LA, 5, we talking about football games? But the Middle East has got like 56%. All right, collectively, all those countries, there they are. And we import. We're importing less today because I told you we've turned more and more of technology. We've learned how to hydrofrack, how to go down and send jets of water mixed with sand and formaldehyde, bad chemicals. We're stripping out our water supply and pushing oil and gas to a place where we can suck it back out. It used to be you left 70% of the oil in the ground because you couldn't get it out. And now we've learned to go back to our old pockets. Technology developing. Do you want a job? Investments. Do you want to do this? All right? But a lot of it comes from Canada. We better stay friends. And Saudi Arabia, Mexico, Nigeria. There's the rest of them. So we diversify. Okay, we're diversified. The oil traps, here are the big 3. Anticline, syncline, anticline. That's the name of folded rock strata. And so the rise of the living dead, I'm rising, trying to get to the surface because they're lightweight. Gas ahead of it, and they get caught by a trap rock, usually shale, mud, okay, can't get through, and it accumulates. So all we got to do is walk on the surface of the land and watch for the strata, which are dipping off to the left here. Wait till they start dipping off to the right. When people discovered that, the strata dipping this way, now they're dipping. Back up, drill there. All right, so people all over the world, go find anticlines, go find it. And so geologists, getting trained in colleges and universities, jobs, booming, go find an anticline. Or a fault. Go find a fault. Oil can't get across a fault zone. It's a barrier. And above it is an offset trap rock, so it collects, it collects, it collects. So there it goes. Rise, rise, rise. Once it gets to the surface, salt domes. Interesting stuff. You've never heard of a salt dome. But salt, from evaporation, now you got that, is a very lightweight mineral, and it can flow. So it rises. It gets buried after evaporation, and it gets buried by other sediments. It's now way down inside the earth, but it's light, and it starts rising. It actually breaks its way, the coffins are erupting, it breaks its way to the surface, and as it breaks, it makes a channel of broken rock. And the oil and gas go, oh, I'm free, follow the salt. Okay, I'm with you, baby. They follow the salt up, and the salt comes up just beneath the surface of the earth, makes a hill. And the oil and gas is going to come up with it, and they get trapped. There'll be a trap rock, if there is a trap rock. All right? Sometimes they'll keep going if there's no trap and go all the way. So there's the salt dome, dipure salt, halite, other salts. And trap rock is an ichoclude. It's impermeable to oil and gas flow, such as shale. So there are the three big. Or there are other kinds of traps. Those are the only ones I want you to know. Here's your good example. Go look for them. Go look for a dome. Go look for a dome. So the salt dome goes up. We learn to drill for it. There it is. Oil like that is rising. It's there. Look at all the salt domes along the Gulf of Mexico. I grew up right there. Goose Creek, Texas, surrounded by oil wells. Why? When we used to go parking, people park now? Ask your mom and dad. We used to go parking under oil well derricks. We didn't do a lot of noise. You couldn't hear what was going on. Whose flashlight is it? I don't know. Okay, so a lot of these things are out there. Look at the domes. Here we are in Iran. Look at the domes. Okay, so this is where salt does. Go. And do you drill right straight down in the salt? No, you got the idea. It's on the edges, right? Go off to the side. So you put the wells all the way around, not straight into the salt. Won't be there. So we learned this stuff. Also, here are strata that are folded. So I can also show you some anticlines we can look for. All there. Wow. So oil. It's been around for a long time. Early Babylonia. The Tower of Babel. Bricks were cemented with oil. Comes to the surface. In Baghdad, Iraq. Baghdad has been around for 5,000 years. And they used to pave the streets with oil so they wouldn't get dusty. They couldn't figure out what else to do with it. But that's interesting, all right? Industry. Persia, in the 9th century, discovered how to make kerosene. Oil is thick. It's really hard to burn, and when you do burn it, it's smoky. But they learned how to make kerosene, which is a lighter fluid, and all you do is heat the oil, and it starts bubbling, and the vapors rise, and then you catch the vapors and condense them, and you get a lighter fluid. And it burns cleanly. Add some oxygen, get the right amount of oxygen, and you got a lamp, put a wick in it, and there you go. So people, we were lighting the world. Lights inside your houses. We don't need candles anymore. Remember, electricity's not made yet. We don't need candles anymore. We got light. I can read at night. Oh, this is so cool. All over the world. Persia was the first. Then the technology was lost, kind of like the making of concrete, and not rediscovered until the 19th century. Native Americans were using it to cement arrowheads to their arrows, axle grease, more kerosene finally came back in the 1850s, so discovery of oil. But early oil was for kerosene. Early oil was for a kerosene industry. Up to that time, we did have lamps from whale oil. We were going out in the world's ocean and killing whales to get their blubber and their oil, and so whale oil. It became an industry, all right, making money. But the discovery of making kerosene, the rediscovery, shut down the whaling industry. So people wanted oil. So the first gusher was in Titusville, 1880. There was no car yet. There was no engine yet. There was no gas. We were just making kerosene. All right, isn't that wild? But very soon the Industrial Revolution was making engines. All kinds of engines. Engines for locomotives, engines for cars, 1890. You know, and so engines for making electricity. Run a generator, I need power. And this stuff is easy to transport. Okay? And so first, Titusville, Pennsylvania, 1859, it's only 69 feet down. West Virginia in 1860, Colorado 1862, Texas, there you are, California, Iran, Iraq. We took out there and helped them find their oil, killed the whaling industry. oil wells everywhere. The early oil was shallow and easy to get at. So gasoline, diesel, I've done this before, propane, oil for heating, oil to make electricity, also paints, plastic, fertilizers, insecticides, soap, synthetic fibers, and synthetic rubber. We used to get rubber from where? Trees, absolutely, yeah. Trees in equatorial parts of the world, trees out of jungles, the rubber tree. But now we can make tires from oil. So in the car, we got cars starting to come online. We need tires made from rubber, so we're doing that. So here, I just came from that town. That's what LA looked like. Lakers, go on. 1904. We don't have football there, though. I'm so jealous. And so look at all the oil. So oil wells were all over the place. Here near downtown LA, and look at the leaking oil. It was a mess with no laws to protect the environment, spilling it everywhere. But Emma Summers, who taught music and piano, quietly started investing in, you want to drill well? You need money? I'll give you money, but I want half of the income. So she started funding wells, and in the end, by 1900, she controlled half of the production in LA's oil field. Isn't that Emma Summers? Way to go, girl. Early writings in the newspapers, she had a husband, but later he's not mentioned at all, so I think she killed him. Way to go, Emma! So there are all kinds of stories there. First oil, she gave $700, and from that it just took off. Woo, woo, woo. That's Long Beach. Look at us. So the early oil was shallow, wells everywhere. All right, not much control. So all of a sudden, oil now is number one. Coal used to be number one. Before that was wood. But now, by the time after World War II, oil was number one. That's what I grew up with. When I smell a refinery, I'm oh, home. Home. That's what I grew up with. I knew when the wind came out of the west, all the refinery smell came right into town. All right. So, U.S. consumption of oil. We are the world's largest consumer of oil. It's over 40%, near 40% of our energy. Gas coming down a bit, floating around. Coal may be coming back up. Hydroelectric and nuclear are way down at the bottom. It's a football game. Energy. But at the top, there are the fossil fuels. And also nuclear. We saw the damage that happened to Japan. Japan just shut down its last nuclear reactor. So Japan, which has no oil, no gas, and a really developed country, came out of World War II, demolished, and now look at it. What's it going to do? It took one earthquake and tsunami to change the complexion of that remarkable country. And what are they going to do next? Let's watch this one. This is going to be interesting. So we've been watching this. The prediction of the end of oil has been around for a long time. We thought one time it was going to end mostly in the 70s. When I say end, when oil is 80% gone, then it's zero for you and me. Because then it's just going to be military. All right? This is what war stuff is made of. So once it's 80% gone, it does nothing for you or me. Prices are going to go so high we wouldn't touch it anyway. We're not going to be driving cars like we used to. We're going to go to a different kind of car. Good thing we got bicycles. All right? So we thought we were going to run out in the 70s, but that didn't happen at all. Here's a prediction for 2010. This is not accurate. 2007. No. We're still climbing the peak. I told you about the soft bottom. Suddenly we were fracking for more natural gas and new oil, discovering new oil, even in this country. We're going out in the deep ocean, in the deep Gulf of Mexico, off of Sweden, the Black Sea, the Baltic Sea, the Caspian Sea. So the game keeps shifting. But what is true here? What is true? Sleeping, sleeping. I was up late last night, Dr. Don't tell me what you were doing. And then natural gas, right there with oil. But we didn't know what to do with it. We didn't know what to do. So natural gas largely is burned until recent decades. Largely was burned out in the oil fields. You go by oil wells. I can remember this. You see flames everywhere, controlled burns, coming out of pipes to the ground. They're burning off the natural gas. Because nobody knew how to move it. I mean, how do you move it? So we had to learn how to make seamless pipes. And we had to learn how to build pipelines and move them All right? And now we've got natural gas coming in and out of every home in America and all over the world. All right? And we can turn on the flame, and there we've got beautiful natural gas. But it took a while. And then Thomas Edison invented the electric light bulb, and that almost killed the natural gas industry. Once they were started, they lit the world. Stockton, California became the first California city to be supplied with natural gas. All right? But now it's quite an interesting resource. Why? Because it is so clean. What's the formula for methane? CH4. It's mostly hydrogen. All right? It's mostly hydrogen. Oh, love that. And so natural gas is formed like oil, and it bubbles out. There's the formula. Mostly methane. Oh, what have I done with my life? Mostly methane, but also propane and butane. So there's other compounds in there. And it comes out. When you burn methane, you're oxidizing. And balance the reaction, it got 1 carbon dioxide and 2 waters. So that's not so bad compared to oil and natural gas. And who's got it? Well, this is the football game. Russia's number 1. Yeah, and followed by Iran, Qatar. We're number 6. Not too bad, but that's where it is. We don't have to import much natural gas. We got pipelines everywhere. We're fighting to build a pipeline from Alaska down here. Will it go forward? Initially, how do we get there? We put out seismic trucks. They set off dynamite, bouncing waves and blast waves through the earth, looking for anticlines, looking for faults. I did this as a college student. I had a job called a jug hustler. And they would put a bale of wire on my back, a bag of geotherms, we call them jugs, on my belt, and they'd send me on a surveyed array, other students, college students, on an array. We'd do an array, dropping a phone, and put it in the ground. And then we all sat down and watched the dynamite blow. And the dynamite would go down in the earth and come back up, giving the image of the structure in the ground. Where's the anticline? Where's the faults? Okay? So great. And we drill. Oh, let's go for it. Well, let's do the math. When is the end? Here is an example of one such calculation. We know our reserves. That's how much is in the ground. We know how much we're producing, how much we're using. Okay? So there is the production of oil, gas, and coal in different units. Doesn't really matter. Do the math. Take this number, divide it by these numbers, and you get a result of 32 years left. Wow. 72 years for gas, 252 years for coal. That's just a model. Basics, you know, Haley, of how much is in the ground, and a lot of people aren't telling you how much is in the ground. What's your question?
Is that to 80% or is that to
That's to 0. So I did it to 0, okay? So it's just a and I did this myself, all right? Taking the numbers out of an oil and gas journal in World Oil. They are certainly wrong. We don't know how much, and we're discovering new, all right? So maybe they're half wrong. Does it matter? We're going to run out, okay, in oil first. It's going to be in your, not my lifetime, I assume, but your lifetime for sure. Well, let's then go around the world and do the same thing per country. Are you going into economics, okay? Or are you going to be a historian? It's all part of the same equation. Saudi Arabia, we know how much they have. We know how much is produced. They got 72 years left. Canada, we know how much they have. We know how much they're producing. 149 years. Let's go to Canada. It's getting warmer anyway. All right? All the way down, we can calculate the number of years left. U.S. doesn't come out so well. 8 years. But that does not include some of the newest finds. But that is one calculation. Regardless, it's stark, interesting, fascinating. All right? And this average on a different set of numbers on a different year gave me not 36 or 38, but 54. All right? So that's what it looks like. Who's got it? Oh, there's the Middle East. Right there. Okay, we know what it is. So, environmental consequences. If humans continue to use fossil fuels in a business-as-usual manner for the next few centuries, the polar ice caps will be depleted, the ocean levels will rise by 7 meters, air temperatures will soar by 14 degrees. So, you know, we've got plenty of time to adjust for this. Do you want to get a PhD? There are students that look just like you trying to figure out, if we got all this carbon dioxide in the air, why don't we just turn it back into limestone? And they're finding ways of doing it, all right? Sequestering the carbon dioxide. Can we do that? So here's another one that said we're going to peak in 2016, and that's probably off too, but it's got to happen. It's got to happen. It's finite, non-renewable, interesting stuff. Because we're getting the soft bottom, we're finding new oil and gas. New natural gas, the Haynesville Shale in Louisiana, we're fracking it, sending down hot water, big find, 13,000 feet underground. We knew it was there, but we did not know how to get it out. Now we've got the technology. And rural families in this part of Louisiana, suddenly they're millionaires. They're millionaires, all right? Also, the Marcellus Shale in Pennsylvania, Ohio, and West Virginia occupies a huge area all the way up into New York. And we're going after it. We're going after it. It's dirty stuff, all right? Dirty stuff, but people are turning into millionaires. Are giving up their mineral rights. But look, would you do it? Would you sell? Would you sell? All right, so there it is. Interesting. In Marcellus, 50 trillion cubic feet of recoverable natural gas, twice the amount we had last year. So suddenly we've got new reserves. Wow. And Texas, the Barnett Shale in Orange occupies a huge area. We knew it was there. We did not know how to get it out. A lot of it is right underneath Dallas and Fort Worth. So what we're doing is going in sideways and using water to sweep it to one side where we can pick it back up. Amazing. And those are all new natural gas. New oil. New oil. You want to invest? The Bakken. I have had people call me on this every year. The Bakken Shale, here it is, in North Dakota, Saskatchewan, down into Montana, a huge area. Look at that. And so, you know, news release, 2008, Department, U.S. Geological Survey releases an assessment of how much is there, 25 times more than we thought. Big stuff going on. What do we got? So down below, 2 or 3 miles down, it's in shale. It's in shale that is usually pretty tight, and we can't get it out, but they're learning how to do it. And so watch this. And this is the last thing we're going to do today. Watch it now. This is an advertisement put out there. And I have people see it and they call me. Is this for real? Is this for real? Yeah, it's real. Don't stay down. Stay down. I know you're excited. Wow. 1951 it was found.
From all of our available data, I say that this is it.
Kind of looks like my
East of
dad.
Williston here, south of Tioga, in the southwest of 6, 155.95.
Notice they're all guys.
There's a fair chance of striking oil in a number
Not
of
anymore.
reservoir rocks.
Neil, over at Bronson's place, they started drilling.
Is that right? Gracious, a bunch of hoodos.
Come on, I want to go see.
Well, all right, let's go take a look.
Let's go take a look. And all but forgotten. But not now. New technology. It is a changing world. Favorable laws.
It's a vast area of land with huge opportunity for oil drilling, but production costs have kept companies from drilling in the Bakken oil formation in western North Dakota. That is, until recently, when oil prices started to skyrocket.